So what we're going to do today is to study the simplest possible three-phase magnet motor, which is synchronous. We have 3 wire coils wired up as U, V, and W from this three-phase power supply, which is set on 1 hertz. U, V, and W all going to the red wires from the coils, and the black straw wired together returns as a star configuration. And we have 3 wire coils of 1,000 turns each, 0.5 wire. In the center we've put a little rotor, a little magnet rotor made of neo-cube magnets, and those are all north, those are all south. So it's just like a bar magnet. Now when we turn the thing on at 1 hertz, we can see that the rotor rotates 1 time per second. Each AC frequency wave is 1 turn of the rotor. So as we turn on this rotor, it's spinning at 1 hertz, 3-phase power, and that's because each of these little coils, U, V, and W, is firing in sequence. U is firing here, then W, then V. They keep firing and firing, and that field from U points that way. The W field's here, the V field's here, and we're getting a rotating magnetic field around the device. So I just wanted to show you, and the magnet's just following the field. You don't need a copper induction rotor. You can just use a little magnet, a little bar magnet. So as we turn the speed up just a little bit, it'll go faster. 3 times per second, and that's 3 times per second. So it's very easy to make a synchronous motor without using a copper induction rotor. Nothing could be easier. Look how much power there is. We're only at 5 hertz. Turn it up a little more. Okay, that's 10 hertz. So the basic point here is that if we have 3 coils wired with UVW power in this arrangement, we can just put a simple magnetic dipole in the middle of them, and it spins up quite easily. And you don't need a squirrel cage. You can use any sort of magnetic dipole, so the rotor can be the magnet. It's incredibly easy. In this case you get a synchronous motor, and you may not need a copper squirrel cage. That's something we'll explore further. So here we have another version of the world's simplest possible magnetic motor. We have 3 wire coils. Now we've laid them flat rather than vertical. We've put a little magnet dipole at the center, north here and south here. They're just little 10mm neo-cube magnets joined together. And over here we have a variable frequency device, and it's wired up to these coils in a row as U, V, and W. Now we just put a little bit of power on this device. At 2 hertz, you can see it's spinning 2 times per second in the center. And you go a little faster, 3, 4, 5. You get really a lot of power out of it, even when the coils are horizontal. That's fast enough to stop you. I don't want it to blow off. So we can have these coils vertical or horizontal, and it still turns quite nicely as a synchronous magnet motor. Nothing could be easier. Do we really need a copper induction squirrel cage? Don't think so for all cases. Thank you. Bye for now. Magnet motors are incredibly powerful. Here I've got 3 coils U, V, W wired up with 3-phase power from this variable frequency device I haven't turned on yet. 3 wire coils standing vertically. In the center I've put 2 cube magnets wrapped with red or blue tape. North pole on the left, south pole on the right. It's just like a bar magnet. And to stabilize the rotor, because they're so big, I put another piece of plastic over the top. Now when we turn on the power here at 1 hertz, you can see the rotor is spinning around 1 hertz, 1001, 2002, in response to the rotating magnetic field. And we speed it up to 3 hertz, quite powerful. 5 hertz was just 1/10 of an AC frequency supply, quite powerful. 10 hertz, incredibly powerful. So when we take the top off to see what this device looks like, we have 3 coils U, V, and W wired. 1 hertz coming out of a variable frequency supply, 50 hertz is mains power, and we see these 2 little neo-cube magnets rotate around once per second. North is red, south is blue, like a bar magnet. And I can't speed it up, but we'll go to 2 hertz, and you can see it goes much faster. I have to stabilize the rotor to get it going any faster than that. When I put a top on it to stabilize the rotor, that's turning it 1 hertz, 2 hertz. And now with the top on it to stabilize the rotor, we can spin it up to 10 hertz quite easily.